Shopping in a supermarket can be fun, right? Plus it is convenient too. If you need cheese, move to the food section. If it's a shampoo that you desire, move to the cosmetic section. Everything is as systematic and convenient as chemistry. What do I mean? Meet me in the studio and you will find out. Welcome to the show. Today I will show you how useful and orderly arrangements in chemistry are, and we will do this by studying the periodic table. We will learn about the periodic trends in the valence, that is, oxidation states as well as the chemical reactivity of elements. We will also discuss the anomalous properties of the first members of a group in the periodic table. Then of course, there will be the all-important exam decoded. Just as a bundle of sticks is harder to break as compared to a single stick, atoms also combine with each other to acquire a more stable state, that is a lower energy state. While the combining capacity of an atom is known as valence, a stable state is a reference to an atom that has 8 electrons, that is an octet in the valence shell. The outermost shell of an atom, the valence shell, is represented by N. In the beginning of the show, you saw how items in the supermarket were arranged according to their category. In the periodic table too, there are such categories which help us locate and identify elements. Two of these categories are transition elements and representative elements. You must be wondering what the criteria of this classification is. It's fairly simple. Elements which require the nth shell to be completed and thus reach a stable configuration are called representative elements. And those elements with an incomplete n-1 shell are called transition elements. And it is these configurations that lend them their characteristic tendencies. Do you know that the valence of representative elements can be found using a very simple mathematical formula? When the number of electrons in the valence shell of a representative element is 4 or less than 4, then the valence is equal to the number of electrons in the valence shell. In case there are more than 4 electrons in the valence shell, then the valence is 8 minus the number of valence electrons. For example, oxygen has 6 electrons in its valence shell. So, its valence will be 8 minus 6, that is 2. The interesting part is that the valence of representative elements follows a particular pattern both across a period and down a group. If you observe, you will notice that the valence first increases up to 4, then it gradually decreases towards the end of the period. In a particular group, the valence of all the elements will be the same. The reason for this is that these elements have similar valence shell electronic configurations. Let us take the example of any two groups from the periodic table. In group 2, all the elements have the same valence. Similarly, group 16 elements also have the same valence. I hope the concept of valence is now absolutely clear to you, because now I am going to ask you a question based on the application of this concept. Predict the formula of a compound that would be formed by the combination of the elements magnesium and nitrogen. While you hone your problem solving skills with this question, I'll take a short break. Welcome back. So did you manage to find the answer to my question? You should have, because this question is one of the most fundamental questions in chemistry. I had asked you to predict the formula of a compound that would be formed by the combination of magnesium and nitrogen. The answer is Mg3N2. This is because the valence of magnesium is 2 and the valence of nitrogen is 3, and the formula of their compound will be based on their combining capacities. Now, let us move on to the valence of transition elements. Most of the transition elements have 2 electrons in their valence shell, and so their valence is 2. However, in transition elements, since the last but one valence shell is incomplete, electrons within this inner shell may sometimes behave like valence electrons. This means that they may be lost along with outermost electrons during oxidation. Here you must note that the number of electrons lost by a neutral atom is called oxidation number or oxidation state. Oxidation number of transition elements range from +1 to the sum of the number of electrons in the nth shell and unpaired electrons in the n-1 shell. Let us now take a look at a table with electronic configuration of transition elements. Please take note of the oxidation numbers, as they will come handy in working out the formulae of the stable compounds formed by these elements. Our young friend here has a question. Maybe you too have a similar doubt, so pay close attention.
I would like to know why calcium, which belongs to group 2, and oxygen, which belongs to group 16, have same valency in spite of their different electronic configuration.
That is a very good question. Till now, we have learned that while combining, an atom tries to reach a stable state. As you have seen, this stable state means 8 electrons in the valence shell, and valence 2 means that the element can either lose, gain, or share 2 electrons to reach the octet. In this case, calcium loses 2 electrons and oxygen gains 2 electrons to form an octet, and so both their valences are 2 despite having different electronic configurations. As you are aware, metals always lose electrons, that is, they are oxidized. The reactivity of a metal is therefore determined by the ease in which it can lose electrons. And if you recollect, we have also learned that it is easy to remove electrons from large atoms. So, the reactivity of metals increases down a group and decreases across a period in accordance with their size. Of the 3 elements shown here, potassium is the most reactive element as it is the biggest in size. In contrast to metals, the reactivity of non-metals depends upon their ability to gain electrons. And just like metals, their degree of reactivity too depends upon their atomic size. In fact, reactivity of non-metals increases across a period due to decrease in atomic size and decreases down a group due to an increase in atomic radius. For example, among the halogens here, fluorine is the most reactive non-metal because it has the smallest size. As you can see, the chemical properties of elements are dependent on their atomic size or radii. Just as your preparation before the exams can indicate the kind of marks you will score, similarly, the reactivity of elements is an indicator of the kind of compounds they can form. We have already learned that if elements are bonded by loss and gain of electrons, the resulting compound will be ionic. Similarly, a covalent compound is formed by sharing of electrons between elements. Another attribute dependent on loss and gain of electrons is the oxidizing and reducing power of elements. While oxidizing agents add electrons and are reduced easily, reducing agents lose electrons and are oxidized easily. So, group 1 elements that lose electrons easily are good reducing agents, and group 17 elements that accept electrons easily are good oxidizing agents. Moreover, oxides of elements which lose electrons are basic, and oxides of elements which gain electrons are acidic in nature. Thus, elements on the left of the periodic table form more basic oxides, and the basic character of elements decreases across the period. Thus, elements from groups 14, 15, 16 and 17 evidently form acidic oxides. That leaves us with oxides of elements in the center which are amphoteric, that is, both acidic and basic in nature. Have you ever traced your family tree? If you do, you will realize that though a lot of your traits can be traced to your parents, you may have some striking similarities with your aunt or uncle. Likewise, when we move diagonally across the periodic table, elements show certain similarities in their properties, though they don't belong to the same group. This is because their atomic sizes are nearly the same. As you can see, atomic radius increases from lithium to sodium and decreases from sodium to magnesium. Due to this, lithium and magnesium have a similar atomic size and thus exhibit similar reactivity and properties. Known as diagonal relationship, the same trend is seen in beryllium and aluminium as well as boron and silicon. Since lithium, beryllium and boron show similarities with elements from the adjacent group, their characteristic properties differ from their respective groups. Do you have a cricket team in your school? Because if you do, you will understand the next concept better. As you would have seen, all the cricketers in your school team do not belong to the same class, but come together because of their skill in cricket. These cricketers are different from their classmates because they have a flair for cricket. Similarly, the first member of each group in the periodic table is different from the rest of their group. If you have noticed, the first shell has only the s orbital, the second shell has s and p orbitals. In comparison, after the third period, there is a shell which has d orbitals also. Therefore, we can say that the small atomic radii and non-availability of d orbitals makes the first elements different from the rest of the group. Speaking of differences, I am sure all this knowledge will make a definitive difference to your exam scores. It's time for a break now. After that, it will be time for exam decoded. All set to take the plunge into exam decoded? Before that, let me take you through a quick recap of what we have learned till now. Today we have seen that the valence is same for the members of a group. On the other hand, in a period, valence increases up to 4 and then decreases. We have seen that transition elements show variable valence. Another important point is that chemical reactivity is highest at the two extremes and lowest at the center. We have understood the diagonal relationship of elements wherein the first element of a group resembles the second element of the adjacent group. We have also seen that the first member of each group is different from the rest of its group. Keep these concepts in mind because they will be useful both in the next segment and your exams. Welcome to Exam Decoded, the foolproof method to better your scores. First, gear up to face the rapid fire session where you will have to answer 5 questions and you will be given exactly 5 seconds to answer each of them. As for the scores, give yourself 1 mark for each correct answer and don't cheat. So, ready to face the rapid fire? Your first question is, valence of nitrogen is 3, true or false? If you answered true, well, you got it right. Let us move on to the next one. Sodium is more reactive than potassium, true or false? The answer is false because the sodium atom is smaller than a potassium atom. The next question is, valence of elements does not change along a group, true or false? The answer is of course true. Let us now move on to a multiple choice question. A stable compound of oxygen and hydrogen can be formulated as A, H2O, B, H2O3, C, HO, D, HO2. If you have chosen option A, then you can add 1 more mark to your score. Now, the last question is, valence of inert gases is 0, true or false? You have guessed it right. The answer is true. So how much have you scored? If you have got all the answers right, well, very good. You are a high flyer. Scores of either 4 or 3 mean that you are an achiever. Anything less than that means that you are a learner. But whatever your scores may be, there is always room for improvement. So do log on to www.topperlearning.com to revise what you have learned till now. Classification of elements and periodicity in properties carries a weightage of 4 marks in your exams and it ranks as important on our weightage meter. And with just a little bit of extra effort, you can score all of those 4 marks. So what are the questions that you can expect from this chapter? Be prepared for short answer type questions of 2 or 3 marks that will test your knowledge ability. For example, you could be asked questions based on the comparison of the reactivity of elements. You can also expect questions on the formulation of compounds on the basis of valence of elements. Let us now answer one such question. Do pay attention to the stepwise distribution of marks as it will help you write better in your exams. Which out of the two, fluorine or chlorine, is expected to be more reactive? As you know, reactivity of nonmetals is inversely proportional to atomic radii. Therefore, fluorine is more reactive because it is smaller in size than chlorine. Easy, wasn't that? And in case you need a little more ammunition to tackle your exams, we have an expert who will give you some noteworthy tips.
Property of element or the chemical properties is related with the number of valence electrons. Valence electrons are the electrons which are present in the valence shell. or valence shell is the outermost shell. So the number of electrons which are present in the outermost shell are responsible for the chemical property of an element. Noble gases are inert in nature. Why they are inert in nature? Inert means they show very less chemical property of chemical reactivity or no chemical reactivity because their valence shell is completely filled.
Systematic is indeed the buzzword today. From the periodic table to your preparation for your exams and even the way you write your answers. But before I leave, some food for thought. According to a Chinese proverb, learning is a treasure that will follow its owner everywhere. So, learn well because then you will excel not just in your exams but in life as well.